Hello! Welcome to lesson 3, the last lesson of the day and the last lesson of module 20. You did a whole module in a day. Awesome. You guys are amazing. Okay, so this lesson is on categorizing plane shapes. So the I can statement says, I can identify whether a plane shape belongs in a category by the number of parallel sides, sides of equal length, and right angles. So we're using those attributes to categorize these shapes. So not all of them are going to be quadrilaterals, I don't believe. Yeah, no, not all of them will be quadrilaterals, and that's okay. So we're kind of moving away from quadrilaterals, but we're using what we know about them to categorize all these shapes. So we are using a Venn diagram. So we know a Venn diagram has two categories, and in the middle is where they overlap. So they have both qualities. So this will hopefully be a good representation of what we've been talking about, how one shape can be defined as multiple titles because they have all those qualities. So yeah, here we go. The Spark Your Learning says, Luis and Paul play a game that has cards with shapes on them. Each shape in the game represents a different move on the game board. How can Luis and Paul sort the shapes below? Show one way to sort the shapes. Tongue twister. Show one way to sort the shapes by their attributes. So, excuse me. So I'm going to draw a Venn diagram. So I'm going to draw two circles that overlap, and I'm just going to do my very best. Yeah, something like that. Okay, so on the left side, I'm going to write right angles, because that is a defining quality. And then on the other side, I'm going to write parallel sides. And then in the middle will be the shapes that have right angles and parallel sides. So this first one, this rectangle, a rectangle has right angles and parallel sides, so it goes in the middle, has both qualities. This parallelogram, however, has parallel sides, but it does not have right angles, so it'll only go over here. Oh, that was a terrible parallelogram. Well, let me try that again. Much better. Okay, so I got that one. Then we have this arrow shape. This arrow shape has right angles here and here, and it also has parallel sides there. So it's got both, so it's going to go in the middle. Oh gosh. This is really testing my artistic abilities. Something like that. We just do our best. Okay, then we have this shape right here that looks like a little corner of the paper got cut off. This shape has right angles and it has parallel sides, so it's going to go in the middle. Like that, kind of. Then we have this rhombus shape, has parallel sides, but it does not have right angles. So it'll just go on the parallel sides part. And then we have this shape right here. I don't even know how to describe that, but it does have parallel sides and right angles, so it's going to go over here. Oops. Just doing our best. Then we have this little tag, cute little tag thing. This one has parallel sides and it has right angles, so it's going to go in the middle as well. Then we have like this X shape. This X shape has parallel sides and right angles, so it's going to go in the middle. I'm just going to do that because yeah. And then finally we have this triangle. This triangle does not have any parallel sides, but it does have a right angle. So we'll go over here. So that is just one way to categorize these shapes. You could do it another way too. let me know what you come up with. Okay, next page, it says, Louise and Paul use a Venn diagram to sort shapes. Now this Venn diagram is a little bit different. We have a circle inside of a circle. So it says, how are the polygons within the outer circle of the diagram related to one another? So all of these in the outer circle are polygons. So they are all closed shapes that are made up of line segments, straight lines. So they are closed and they are made of line segments, and that's pretty much all that defines them as polygons. Made up of line segments. How are the quadrilaterals within the inner circle related to one another? Now these quadrilaterals are all four-sided shapes with four angles, because that's the definition of quadrilateral. Four sides, four angles. Some of them are parallelograms, some of them are not. What ties them all together is that they're four sides, four angles. Part C says, how are the polygons as a category related to the quadrilaterals as a category? So this would be all the shapes in the circles are polygons. So even though we classify these as quadrilaterals, they are polygons because they are closed and they are made up of line segments. So that's what you'll write down. The quadrilaterals are polygons because they're made up of line segments and they're closed shapes. Then part D says, draw a shape into each circle of the diagram. Explain how your shapes belong in that circle. So if I were to draw a polygon in the outer circle, it is going to have more than or less than four sides and four angles. Why? Because if it was four sides and four angles, I would just put it in the quadrilaterals. So I don't want that. I want something more or less. So I'm going to do a triangle. There we go. And then for my quadrilateral, to define it as a quadrilateral, I need exactly four sides and four angles. So I'll do a little square. Okay, draw a shape that does not belong in either circle of the diagram. Explain why it does not belong. Now this is interesting because to be a quadrilateral, you have to have four sides. To be a polygon, quadrilaterals are polygons, but to be a polygon, you have to have closed shape made of line segments. So if I drew something like a heart, okay, that would not go in any of the circles because it is made up of curved paths, and that polygons are not made up of curved paths. So that's why this shape doesn't belong in either circle. Okay, so the turn and talk says, is a quadrilateral always a polygon? Yes, a quadrilateral is always a polygon because the only requirement for a polygon is to be closed and made up of line segments, and all quadrilaterals are closed and made up of line segments. Now, it also says, is a polygon always a quadrilateral? No, because a quadrilateral requires more specific attributes. Okay. Number 2, it says, here is a group of plane shapes. So remember, if it's a plane shape, it's on a flat surface. Which of the plane shapes are quadrilaterals? Write the letter of the shape. So shape A, yes, is a quadrilateral because it has four sides, four angles. C is not because it has three sides and three angles. E is not because it has much more. G is because it has four sides and four angles. B is, D is not. I almost thought it was at first, but it's not. F is a quadrilateral and H is a quadrilateral. And then it says, which of the plane shapes are polygons with all sides of equal length? Write the letter of the shape. Now let's see. I would say only B and G, maybe D and C. C for sure, actually. C for sure. Oh, I want to say E. I'm going to say E. Am I right, book? Yes, I am. Okay, so C, E, G, B. Oh, I didn't even notice that it's like going up and down. I thought it was going across. So we missed B, but yes, B is. And D. I want to say D. Am I right? Yes. Thank you, book. Not F and not H. So B, C, D, E, and G are polygons that have equal, all the sides are equal length. Use the Venn diagram to sort and compare the shapes. Label each circle of the diagram. Place the letter of each shape in the diagram. So it says polygons are on the left. And then shapes with all sides of equal length. So all sides equal length on the right. We're just using how we split it up before. So let's think about shape A. Shape A is a polygon, but is it also do all sides have an equal length? No, it's just a polygon. It is a quadrilateral, but that's not what we're categorizing right now. Let's see. Shape C is a polygon and all the sides are equal length, so that goes in the middle. Shape, oh, I forgot to go up and down. I went straight across again. B is a polygon and all sides are equal length. I wonder, does it want us to do polygon or quadrilateral? Yeah, it makes sense to do quadrilateral here. So I'm going to mix that up. Sorry. So this side is quadrilateral. This makes more sense. This side is quadrilateral. This side has all sides of equal length. So we're still okay with what we've done now. A is still a quadrilateral. Sorry. Okay, so A, B, C, and then D. D is not a quadrilateral, but all, oh wait, that's going to change. Just kidding. It's going to change C, because C is not a quadrilateral, so C is only on the right. And then same with D. D is not a quadrilateral, but all sides are equal length. Okay, here we go. E is not a quadrilateral, but all sides are equal in length, so that goes on the right. F is a quadrilateral and all sides are not equal. G is a quadrilateral and all sides are equal, so that goes in the middle. H is a quadrilateral, but not all the sides are equal, so it goes on the left. Okay, we figured it out. So on the right, where it has quadrilateral, we have A, F, H. In the middle, quadrilaterals and shapes that have all equal side lengths is just B and G. And then on the right, the sides, or the shapes that have all sides have equal length, that is C, D, and E. All right. See, even teachers get mixed up sometimes, and that is okay. All right, the check understanding says, circle the plane shapes that are polygons with exactly one pair of equal length sides. Draw a line through the shapes that appear to have exactly one pair of parallel sides. Okay, circle the plane shapes that are polygons with exactly one pair of equal length sides. Draw a line. Okay, so that would be like this. So this, I would circle that because that has one pair of equal length sides. They're not parallel, so I would draw a line through shapes that have exactly one pair of parallel sides. So that has exactly one pair of equal length. This one has exactly one pair of parallel sides. This has two pairs of parallel sides and two pairs of equal length, so I'm not going to do anything to it. This one has nothing going on. This one has exactly one set of parallel sides, so I'm going to draw a line through that. And then the rhombus has 2 sets of parallel sides, so I'm going to do nothing to that. Oh wait, but then this one has 2 sides of equal length. So I would circle and put a line through it. All right, last page. Complete the Venn diagram. Oh good, it's done for us. We just have to put the letters in. Place the letter of each shape in the correct place in the Venn diagram. So our Venn diagram on the left is quadrilaterals. On the right are polygons with at least 1 right angle. So 1 right angle, quadrilaterals. Shape A is 1, 2, 3, 4, 5 sides. So not a quadrilateral, but it does have a right angle. So that will go on the right. Shape B, also not a quadrilateral, but it does have 1 right angle, so that goes on the right. C is a quadrilateral, and it does not have 1 right angle, so that's going to go on the left. D is a quadrilateral, and it does not have a right angle, so that's going to go on the left. E is a quadrilateral, and it has 4 right angles, so that's going in the middle. F is a quadrilateral, and it has right angles, so it's going to go in the middle as well. And G, this one is funky, but I don't think any of the angles are right angles, so I think it's going to go on to the left because it's a quadrilateral. Number 3, place the letter of each shape in the correct place in the Venn diagram. So we have rectangles and rhombuses. Remember, the only requirement for a rhombus is that there are 4 equal sides. Okay, so shape A. Juno, stop barking. So place the letter of each shape in the correct place. I don't. Juno's really mad. Okay, we're all good. We're all good. Okay, so shape A is a rectangle and it's a rhombus because it has 4 equal sides, so that's going to go in the middle. Shape B is not a rhombus because it does not have equal sides, so that's just going to go on the rectangles. And then shape C is not a rectangle because it does not have 4 right angles, and so it's just going to go onto the rhombus side. Same with D. Actually, no, D looks like there's right angles, so that would be a rectangle and a rhombus. And then E is just a rectangle because it does not have 4 equal sides. And then F is just a rhombus because it does not have right angles, but it does have 4 equal sides. Okay, so then open-ended it says, choose 2 different quadrilaterals to compare. How are they the same? How are they different? So pick 2 quadrilaterals, so 4-sided, 4-angle shape, and talk about how they're the same and how are they different. So maybe like trapezoid, parallelogram. They both have at least 1 set of parallel sides, but they're different because a trapezoid doesn't have to have both sets, or it doesn't have to have 2 sets of parallel sides. Or you could talk about a rhombus and a square, how they both have 4 equal sides, but a rhombus doesn't have to have right angles. Okay, and then, oh, that just answered number 5. Is a square always a rhombus? Is a rhombus always a square? Explain. A square is always a rhombus. A square is always a rhombus because a square always has 4 equal sides, and that's the requirement for a rhombus. A rhombus is not always a square, though, because a square has to have 4 right angles, and not all rhombuses have right angles. So, there you have it. That is Module 20. We did it. Oh my gosh, I can't believe it. We do need to do the review tomorrow, but that should go really quick. Tomorrow's the last day of school. I cannot even believe it. So, do your best to get this done. I know it was a lot. 3 lessons in 1 day is a lot. I know. So, I'm so grateful for you for working hard. I'm so proud of you for doing your best. Let me know if you need anything. Love your guts. Bye.